Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 93 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Hopefully by lesson number 93, most of you guys already have your gear, but if you don't, look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my solution to the homework assignment that I gave you in lesson number 92. But I must first ask, how many of you were successful? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay, hopefully most of you guys got it because it was really sort of a combination of several things we've done in the last few lessons. But what the assignment was to hook up your Raspberry Pi Pico W, to hook it up to 4 LED and a button and create a binary counter, a binary up counter using nothing but the state machine. So the only thing that you can do in Python is just set up the state machine and download the code. Everything else has to be done down in the state machine. Because why? We want to start getting where we're problem solving. We're not just out looking for someone else's libraries or someone else's solutions, but we're thinking through some of these rather difficult or rather challenging problems and learning how to problem solve, learning how to think outside the box, learning how to think creatively. Okay, hopefully that makes sense. Let me get out of your way. Okay, I guess we should probably start by just recapping what our circuit is. This is the same as what we've had in the last few lessons, but we have 4 LED. This LED, the long leg, is hooked up to GPIO pin 16. Then this one's 17, 18, 19. So the long legs of these LEDs are GPIO pin 16, 17, 18, 19. Each one has a 330 ohm resistor that takes it down to ground. Now I have 2 different buttons. The buttons are going to be using a pull-down resistor, and so we have the left leg of each button connected to the power rail. The power rail is established over here with GPIO pin, or with physical pin 36. Okay, this physical pin 36 is creating the power rail, and then we've got these. Then this pin, the right leg, is connected to GPIO pin 14, and this one is connected to GPIO pin 15. So hopefully that makes sense. Now what we're going to do is, using only, and I mean only, the state machine, we are going to come in and we are going to make a binary counter. Okay, we are going to make a binary counter that clicks up with each touch of the button. So I'm not going to import time because we're not using time. We're not doing anything in Python. So I'm going to from machine, I'm going to import pin because we will need to set up those 2 input pins. And then we're going to import our friend RP2, which is our state machine library. And now we're going to give it the @ decorator, putting Python on notice that we have machine code incoming. And then we're going to use the library rp2.asm for assembly, and then our assembler PIO for programmable input output. And now we're going to initialize those out pins. So I'm going to say out underscore init, like that, is going to be equal to, we're going to do the rp2.pio.out low. So we're going to start by, when the state machine starts, all those 4 pins that we're using are going to be low. We have this dangling comma, which I hate. And then we say, how many pins are we going to set low? Well, starting with the out base pin, we're going to do a total of 4. So it will be that one and 3 more. All right. Now we've got to set up our out shift direction. I just find it seems to be needed. Out underscore shift dir is equal to rp2 dot, and I got to get this down, I think, where you'll be able to see it. Okay. rp2 shift out shifter is rp2 dot pio uppercase dot shift right, like that, and that should be an underscore, and then we're going to close this. Okay, so you guys see that? That is our giving notice that we have incoming machine code. I'm going to move it back up there because I gave you a chance to see it. Okay, now what are we going to do? We are going to define, and what are we going to do? We are going to define our program, which I'll just call binary counter, like that. And then this is the function. I'm going to say the wrap target up here at the top. And then I'm going to say the wrap down here, like that, just to get that set up. But now I want to come down and kind of finish up by instantiating the machine. So I will do that. I will call it state machine 0, and that is going to be rp2 the library dot state machine, the method, and then which state machine? Let's use state machine 0. And then what we're going to do is we're going to say that the program we're going to run is the bin counter that we just set up. Okay, and now we're going to set up our in base pin. So in underscore base is going to be equal to pin, which pin 14. Okay, I think I'm going to have to move that down so you can see it as I type. I know you hate it when I am typing and you can't see it. Okay, so we're going to have pin 14, and we need to set that as an input pin. So pin 14 is going to be a pin.in, like that, and then we're going to have a pin.pull down. Okay, so we are initializing that pin as a, we're initializing that pin, or we're turning on the pull down resistor on that pin. Okay, now we want to run slow, so we're going to say our frequency is 2000. Okay, and now we've got to set, I've got to get out of your way further, we've got to set our out base pin. Our out base pin is 16, and so it will start at pin 16, and then remember up at the at command I said 4 pins, so that means it'll be 16, 17, 18, 19, which is what we set up here. Okay, so that all looks good. Okay, you've had time to get that, so I'll move that back up. And now we will go ahead. What's the only other thing that we need to do down here? We need to do the S, we need to do, it's missing a, okay, I missed a, I better show it to you. Hopefully you guys probably saw that I did not close my pin method there. Okay, now everyone is happy. Okay, so now the only thing that I need to do now is, just turn on the state machine. like that, make it a 1 to turn it on. All right, now what we've got to do is we've got to come in and write our machine code. I like to get the framework of the program working first, and now I can come in and I can focus on the machine code. Okay, now what we have is we have the wrap target, and then what we have is we have the wrap. What do I need to do? I need to go ahead and I need to set my X register to 0B1111, okay, like that, 0B1111. So that would be the number 15. So the number 15 is in the X register. Now what I'm going to need to do is I'm going to need to loop. So I'm going to label the top of my loop as bit loop, like that, okay, single quotes. Work nicely. All right, now I'm going to move. No, I'm not. What I'm going to do is I'm going to wait. So it is going to sit there. Right now, everything is off. Okay, everything is off. I am going to, okay, yeah, we'll just do it like this. So everything is going to be off. And then what am I going to do? Okay, I'm going to wait. I'm going to wait for a 1. Why? Because these have pull down resistors, which means as they sit, they're sitting with a 0. Okay, when I press it, it'll get a 1. Well, I want to wait till I get a 1. Till I get a 1 where? On the pin. On which pin? Pin 0 relative to pin 14. What is pin 0 relative to pin 14? It's pin 14, so it should be reading this button here. Okay, now we might want to use pin 15, so I better come down here and go ahead and set that up. Pin 15 is equal to pin, and we do the same thing as pin 15, and it is a pin.in, like that, and then it is going to be a pin.pull down, like that. And now what have I done? If I come in and I go to pin 1, that would be pin 1 relative to 14, which would be pin 15, which is what this is hooked up to. So if I'm going to be referencing over to pin 15, I better have pin 15 set up where that pull down resistor is activated. Hopefully that makes sense. Okay. So now that was just a little bit of bookkeeping, but here is my label bit loop, so I'll come back up to the top. I don't want to come all the way to wrap target because I want to just set that 1111 one time, and then as I count, it will be working with that. Okay, now I wait. And what I need to do is debounce the switch. So I'm just going to do a no op. I'm going to use a precious line of code here. So since we only have 32 lines of code, this is pretty precious. I found that really to be rock solid, we need to have two no ops. Okay, so why? Because if I'm at 2000 hertz, each clock cycle is a half a millisecond. And so 31 plus the 1 would be 32. That would be 16 milliseconds, and 16 milliseconds and 16 milliseconds is 32 milliseconds. And that I find to be enough to just absolutely positively debounce the switch. Okay. Now, what that's going to do is it's going to find that button push. Okay, it is going to find that button push, and then what I'm going to need to do is the button is down. Now I'm going to wait for the button to come up, and that's going to be a 0. Okay, and then on what? That will be waiting on pin, and which pin again? Pin 0, which is pin 14, but this time instead of waiting for the pin to go down, it is waiting for the pin to come up. Now what we are going to need is we debounce. We debounced on the way down, we need to debounce on the way up. So we put those in there again. No op, like that. Okay. Now if I run this, what is going to happen? Let's see. We get an error in line 16. Frequency, outbase, 14 pin. Wow. Bin underscore counter. I hate looking at these long lines of code and trying to figure out what I did wrong. Okay, it is SM0 RP2. You guys help me. Do you see it? Then it is 0. It is bin counter. That's their comma. And then I've got the end base, end underscore base, pin 14. This is pin, uppercase N, pin dot pull down. I don't think that space makes a difference, but I'll take it out. And then I have frequency of 2000. I have out base. Out base is not done that way. Out base on. Let's see. I see what my mistake is. Okay, so what I was doing is, I'm sorry, I'm going to come in, I'm going to take that out. I'm going to take that out. And then out base is equal to, hopefully you guys saw this. I've taught this so many times, you should have seen this. Out base is going to be pins equal to pin 16, like that. And then I just took the extra spaces out. All right, so now let's run this. Okay, so it runs now, and what happens? Absolutely nothing. Why does absolutely nothing happen? Because I never moved my number. I never moved my number to my pins. And so where are we going to do that? Well, I want to start at 1, 1, 1, 1. So I think that probably I want to go ahead and put those on my LED before the button pushes, because I should start at 15. So now I'm going to come in and I'm going to move 2 pins, my out pins, what? X, move X to the pins. Now when I run it, I've got 15 and nothing happens. Now that is a somewhat surprising and shocking result. Okay, so what is this doing? It's moving X to pins. Okay. Look what I didn't do. I came down here, but I never jumped back up. So what I got to do is I've got to put what's kind of equivalent to my for loop. I've got to jump, JMP, okay. And when I jump, I want to decrement X. So X decrement. So this will keep jumping as long as X is not 0. It will keep jumping as long as X is not 0. So if X is 3, it will jump, and then after it jumps, it will decrement X. And so it'll come down, X is 3, it will jump. As it jumps, X is 2, it comes down, X is 2, it will jump and X becomes 1. It will come down, X is 1, and it will jump, X becomes 0. And then when it comes down, X is 0, and then it goes on down, because it will stop looping when X is 0. And each time through, it will decrement X. And where am I going to go? I'm going to go to bit loop, like that. Okay, now let's see what happens. Now, okay, I started and they all come on, and now I press the button and I went to 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And back around the horn to 15. Boom! boom, success. But you throw a yellow flag at me and you cry foul, saying you said to make a count up binary counter and you just did a count down binary counter. No fair. The assignment was to do a count up timer. Indeed. Okay. So what do I want to do? I don't want to move X. I want to move the what? The invert of X. So what's it going to do? It's going to start not with 1, 1, 1, 1. It's going to start with the invert of that, which is 0, 0, 0, 0. Then it's not going to go to 1, 1, 1, 0. It's going to go to the invert of that, which is 0, 0, 0, 1. So I think if I just change that to invert, we might come over here and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. We have success. Now this again is the amazing thing. The Python program isn't running. The Python program is not running. Okay, I could even come in here now and do an sm0.active, and I could turn the state machine off. And now if I come over here, the state machine doesn't work. I could come over here and give a command, sm0 active, and turn it on with a 1. And now if I come in, I count up again. Okay, that is absolutely amazing. Now this is the amazing thing to me. I can come in and actually kill the IDE. I can actually come in and kill the IDE, and all I'm getting is power to the Raspberry Pi Pico W, and the only thing running is just the state machine, and I am getting the input from the button and the output going to the LEDs. Man, I don't know. Maybe it's just simple things make me excited, but I am really, really, really enjoying this. And I hope that you guys are having as much fun with it as I am. Okay, so I'm not going to give you a homework assignment. Your homework assignment is to just make sure that you can do what I just showed you. If you weren't able to do it on your own the first time, that you can turn the video off, you can hide my program, and you can go in and now program it on your own without looking at what I did, just thinking through it. Okay, now what are we going to be doing next week? I'll kind of give you a heads up as far as what we are going to be doing next week. So I did pin 14 here. Now if I wanted to use this pin, instead of saying pin 0 relative to 14, I would have said pin 1 relative to 14, and then this button, this button would have, this button would have been the one that made it work, okay? But if you think about that code, let me come back up here to Thani. Okay, I guess I shouldn't. I got so excited about killing it, I probably shouldn't have killed it. Maybe I can just pull this over here. Give me just a second, please. Okay, yeah, let me come over here like this. Okay, so this is, and you don't see that. Okay, so this is what we were doing, and right, if I would have made this a 1, and if I would have made this a 1, and then I have pin 15 set up, and 15 would be 1 over from 14, I could have done this with this button. Okay, but what I want you to see is the way that I've taught you today, I can sit there and I can just have loads of fun with this button. But what's the problem? If I wanted to use 2 buttons, what is the problem? If I am waiting on, let me turn these back to zeros. Okay, so this will put it back on 14. If I am sitting here waiting on input from pin 14, I am not seeing any action that might happen on pin 15. I am not seeing any action that might happen on 15 because I am pausing the program here, waiting to see something here. So if I wanted this one to go up and if I wanted this one to count up and this one to count down, it's sitting just looking at this pen and it would never see anything here. So we need another way, we need an additional way to get input from the pins. Now weight is really great, and anytime you just have one button, there's all types of different great places that you use weight. But what we're going to need to do is we're going to need to now go in and figure out how we can interact with two different pins. Okay, I hope you're having as much fun taking these lessons as I am making them. As always, right now, I want to give a shout out to you guys who are standing with me on Patreon. At this point, the only thing that is keeping me in the game and making quality content for YouTube is you guys that are supporting me at Patreon. And I really want to give you a big thank you for that. You can also help me by leaving a comment down below. You can also help by giving the video a thumbs up. If you haven't already, make sure you subscribe to the channel. When you do, make sure you ring the bell so you'll get notifications when future lessons drop. And as always, most importantly, share this video with other people, because the world needs more people doing engineering and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.